I'm Rob from Precision Zone, and today we're going to go over a basic test that you can do in your facility to help troubleshoot some faults you might have. Two common faults that you could get are overcurrent or a ground fault. One of those two faults or alarms in your machine might give you suspect to see if you have a grounded motor or grounded cable. So what we're going to be using today is a digital multimeter from Hioki and Hioki's 1000 volt meter. The first thing that you're going to do before you do anything is make sure you power down your machine and secure the power from the main breaker. After that's done, you can take your multimeter, set it to the AC volt scale, and we're going to double check to make sure that there's no power coming out of the drive. So you're going to check from U to V, we're going to check from U to W, and we're also going to check from V to W to make sure that we have nothing else more than 1 volt. If we do, then that means there's a problem with the drive and we don't want to touch it. So now that we've verified that the power is off, it's okay to go ahead and disconnect the power cable. The reason why we're going to disconnect the power cable is because if you mag this cable while it's still connected to the drive, you're going to damage your drive and it's going to need repaired. So we're going to take our meter, and with it powered off, we're going to take our ground clamp and hook it to the ground of the cable. We're going to turn it to 1000 volts, which is the most powerful. Press the release, hold the lock, and we're going to check between U and V and also W. So what we've looked for is anything at ambient temperature above 300 to be okay. And so since this cable connected to the motor made above 300, we would say that there's no problem with the grounded motor. But let's just walk through the steps and if it were grounded. So right now the stator has voltage charged up to it. So what we're going to do is release any of that discharge voltage by touching the phases to the ground. So the first thing we're going to do is we'll check the cable now. So with it disconnected from the motor, we're going to hook our ground clamp of the meter back onto the ground clamp of the cable. We'll go from U, V, W. This cable tests perfect, so we know we don't have a problem with the cable. Now we can go to the motor. So when you're looking at the power connector on your motor, typically A, B, and C is going to be your U, V, and W, and D is going to be the ground. Now that holds true with 4 pins, 6 pins, 7 pins, 8 pins. Traditionally, that's how the pin layout is going to be. So we're going to want to find a good ground to our motor, and if this motor is in your machine, you won't be able to grab the face of it. So in order to find a good ground, you can hook it, turn on the meter, and then touch the ground pin. If it grounds out, that means you have a good ground. Even though this is a painted surface, it's a good ground. So what you're going to do now is check U to V to W. And as we already know before, making it from the end of the cable, this motor is perfectly fine, so we have no problem here. But then if the motor was grounded, you know that you would need to send it in for repair. So I hope this video helped. If you have any more questions, you can call the number on the screen, or you can visit us at precisionzone.com. Just keep in mind, we do free motor evaluations and offer 12-month warranties on all the motor products we repair. Thanks for watching.